Hi everyone, how are you? Today's edition will speak about the gases law, and we have three of them that we have to understand how they are working and how to apply them for each part. First of all, we have to understand that the pressure here is the applied force over an area. We calculate it by this formula P equals F over A. P is the pressure, force is the Newton, and the area here is the area which is measured by meter power to 2. Pressure is meter with Pascal, or atmospheric pressure, and the force with the Newton. You have to understand that each part of them is different from part to another part, and also the Pascal has to be known as a Newton per square meter. You have to understand also that commonly used non-SI unit for the atmosphere, the pressure of the atmosphere, we call it the atmospheric pressure. It equals directly 1.013 multiplied by 10 power to 5. So when he speaks about an atmospheric pressure, it gives you directly 1.013 multiplied by 10 power to 5. And this is a fixed number, it doesn't change at all. For any kind of a change that you can find here, if you have it to change it from part to another part, you can see here that 1 meter equals 100 centimeter, 1 centimeter equals 0.01 meter. You have to know also that the pressure equals force over A. So from the triangle here, if I want to get any kind of force, we have to multiply pressure by the area. He gives me here the area and also the pressure down, because it's an atmospheric pressure, so it's 1.013 multiplied by 10 power to 5, and the area here, as you can see, is 0.25. Because it's a centimeter, I have to change it to be a meter, so it's 0.25 power to 2, and then you can bring here the force. Why did I power the side of the cube by 25 power to 2? This is because I'm getting an area. The area is both two dimensions, length and width, and both of them, they are giving you the 25 multiplied by 25. Okay, so if you are speaking about the macroscopic gas law, you have to know that there's a relation here between pressure and the volume, a pressure with a temperature, temperature with a volume. For each one of them, they have a name. Between the pressure and the volume at a constant temperature, when the temperature is constant, we call it the Boyle's law. Boyle's law here, it speaks about the pressure is inversely proportional to the volume, which means when the pressure increases, volume decreases, or when the volume increases, the pressure decreases. So you can find here that any graph that you can draw it, even if you have made any kind of an experiment, it gives you this slope, which means they are differently, or they are inversely different to each other. A macroscopic gas law, Boyle's law, it says here when it gives you any kind of a problem, or it speaks about any thermodynamic system, if there's a change happening between pressure and volume at a constant temperature, so you can calculate it by this. P1 multiplied by V1 equals P2 multiplied by V2. P1 is the pressure for the first part of the gas. V1 is the volume before applying the pressure, and P2 and V2 is the second, and the volume and pressure, both of them. Okay, so he said here, if I give you an example for both Boyle's law, you have to know that 1 liter equals 1000 milliliter. So if I want to compress nitrogen at 1 atmospheric pressure from 750 milliliter, this is the volume 1. So what's going to be the pressure when these part would be found the same as it changed to 500 milliliters? So volume 2 is 500, volume 1 is 750. That's how can I get the P2? And the answer here comes from the relation P1 V1 equals P2 V2. You want P2, so can I get it by here multiplied 1 with the 750 and divided by 500. The second law here, so we got the first one is named Boyle. The second law here is named Charles, and the Charles here speaks about the relation between volume and temperature when the pressure is constant. They are here directly proportional, which means if the volume increases, temperature increases. If the temperature decreases, the volume decreases. So they are related to each other very strictly, and both are increasing or decreasing with the same amount. So the Charles law, he said here that V1 over T1 equals V2 over T2. V1 is the volume of a gas, T1 is the temperature that you are starting with. If you change it with a volume or a temperature, the other one will have to be changed also, but both have to keep both equal. He said here as an example also, you have to first change any temperature from Celsius or Fahrenheit into Kelvin. You can't work with any other degree, just be in a Kelvin. So I said here, as you can see, the gas here, volume 1 equals 450. It changed from 45 degrees Celsius to minus 5 degrees Celsius. So I have to get the calculations for the K, which is the Kelvin, which equals C plus 273. T1 it gives me 318. T2 gives me 268. From the relation V1 over T1 equals V2 over T2, I can bring V2 directly by my calculations. The third one is the Jay-Lezak. Jay-Lezak law here, he has a relation between both P and T. P is the pressure, T is the temperature, and both are directly proportional to each one, which means that the relation will be the same like before. P1 over T1 equals P2 over T2, and this happens when the volume is constant. So I have three laws right now. I have Boyle, I have Charles, and also I have Jay-Lezak. Both or the three of them speaking about the gases. You fix only one part, and the other two they are changing. The only one that has inversely proportional was the Boyle one between pressure and volume. Charles law, it's between temperature and volume, and the third one is the pressure with the temperature. You have here learning check that you can get through it. Check them first. You have here an example that already answered. You finish another one here being finished for you to get it back. Please answer question 3, 4, 5, and 6 inside a notebooks or even an online data. Submit it back for me, and thank you for watching this video. Bye.